Absolute encoders are used in many applications that require speed, position, angular displacement, and directional feedback. An encoder is a device that converts linear or rotary movement into digital or pulse signals. The most common type of feedback device is the absolute optical encoder. An absolute encoder consists of the four major components: a rotating encoder disk, a light source such as an LED, a photodetector as the light sensor, and a signal conditioner that converts the signals into square waveform. The encoder disk consists of a series of opaque and transparent tracks mounted to a rotating shaft. The tracks of the disk are arranged concentrically around the center of the shaft. Photodetectors assigned to each track designate the resolution of the encoder. The higher the number of concentric tracks, the higher the accuracy. A light source located on the opposite side of the photocells passes light through a capture plate. As the encoder disk rotates, light is either transmitted or blocked according to the pattern. The received light provides a 4-bit word that indicates position of the actuator or device the encoder is mounted to. The most common types of numerical encoding are decimal, binary, and gray code. In a 4-bit encoder, there are 16 unique combinations or numeric code every 22.5 degrees. Gray code is designed where only one bit changes at a time, contrary to a binary system where one or more numbers change in the word. By changing more than one number of the word at a time in the binary system, the possibility of positioning errors is greater, leaving gray code the preference in precision applications. For robot applications, absolute encoders are commonly used for precise positioning operations. The actuator in this example demonstrates the function of the absolute encoder in operation. As the actuator moves to push the carton, the encoder provides feedback that it has reached the user-defined position. The actuator then moves back to the home position, verified by the encoder, and completing the cycle. Using feedback devices closes the loop in motion control systems.